Legacy lighting controls. It's important for us to know what has been acceptable in the past under the Canadian Electrical Code, but not necessarily what we could then still install today. A best example of that would be different types of lighting controls that until 2018 were permitted in most installations. The challenges we run into with older types of lighting controls is typically in the form of cable. How are we going to wire it? Well, there's lots of different types of cables that we can use: Lumex, BX, Tech, tray cable, all of those, and that is where the challenge begins. Most circuits are going to be in one of these two basic forms. Either we have a standard circuit or lighting circuit that uses a standard light switch, which we all know is referred to as a single pole, single throw light switch. It's on or off and it controls the light. On the circuit down below, what we're using is two separate three-way switches, which are known as single pole double throw. Single pole double throw. And what that means is that we can control the light independently from two different locations. In both of them, we have a few different ways in which to describe or identify the conductors. This here would be the line conductor, or sometimes referred to as the hot. This would be the switch leg. And then we would have the identified traveling back. Likewise, on the bottom, we have the same thing. We have a line conductor. We have a switch leg, and identified. But in addition to that, we also have travelers. And the travelers are the conductors that terminate from one three-way switch to the next. So where do the challenges come in when we're dealing with cable and these two very standard types of lighting circuits? Well, first we need to understand that cable will only come in a few different color variations, unless you're getting into some really specific industrial controls. But usually at that point, we are not working with a 2 or 3 wire cable, but something in the realm of 10 or 12 conductors. So these cables here are pretty typical for industry. If you get a 2-wire cable, typically it's going to be black and white. There are some cables that we can get that are black and red insulated conductors inside, but those are pretty few and far between, and usually you're only using them for 240 volt heating circuits. The 3-wire cable below you see is in two different variations. Those of you who do residential will recognize this one as a typical Lumex or Romex 3-wire cable, red, black, and white. Whereas down here, if we were using BX on an industrial site, or maybe Tech or ACWU, a 3-wire cable has the option of coming in either red, black, white, or red, black, blue. Now, the challenge in wiring these standard lighting circuits is that the white conductor does not get to be used in any way we choose. There are some specific parameters around that, which are covered under Section 4, Uses of the Identified Conductor. Let's take a look at how these will manifest themselves within a given example. So here's a very basic circuit. I've got a switch and a light. I'm going to do a cable installation along here, and then from the panel down through this section, I'm going to use conduit. Well, that means that from the panel, I'm going to have a black conductor connecting to my switch, and then I'm also going to have a white conductor coming along with it. And it has to, because this would be a single cable. We would say this is a 2-wire cable, 14-2. 14 gauge, simply because a 15 amp circuit is the most common we're going to see. Inside this box, we're going to have a moret. So that's my moret. And then from this box to the light, we're going to have another black and a white conductor. And again, we're going to have 14.2 traveling between these two boxes. Now, if we were to do conduit, I'm not going to draw the conduit, rather I'm going to draw the conductors inside the conduit. I would have a black conductor, or whatever color was required from the circuit, and then we would have a switch leg, which typically is going to be black also. And then traveling all the way back would be a white conductor. And there would be no moret anywhere within the circuit because it has no connection to the light switch. So this was a common way for us to do our circuits, and this is the way that is now required under the Canadian Electrical Code from 2018 going onward. Now, other types or variations of this were found in pre-2018 installations, and those centered around a type of installation called a dead-end switch. So this is the example of a dead-end switch. The dead end means the switch is at the end of the circuit rather than it being at the very beginning. And the method we would use to install this would be to make a splice in the lighting box. So our home run, our black and our white conductor, would travel from the panel into this box. I'm going to draw my white conductor on top this time. I'm going to go all the way around to there, and it connects into the light. At this point, we would have a moret. And then we would connect to the moret the white conductor going all the way to the switch. And then from the switch would go back to the lighting fixture and terminate, thereby completing the circuit. So we still had a 14.2 here and a number 14.2 here. The difference in this type of wiring was that we had a white conductor terminated to a black conductor, and that was permitted under Section 4. They wanted us to do it this way to ensure that we did not have two white conductors going back to the light. So if you encounter something like this in the field, it's important to realize that if you have a smart dimmer or a smart device that you want to install here, and there's only a white and a black, well, in fact, it won't function because you don't have a true identified or neutral connection between this box and the panel. Really, all we have is a hot and a switch leg, and it's easier to visualize by doing the conduit installation down here. You'll notice the conduit installation is much more straightforward. All we're doing is going black conductor all the way to the switch, black conductor out to the light, and then white conductor back to the panel. Now again, this cable installation done pre-2018 is totally acceptable. However, you're not permitted to do them new nowadays. The reason that we would have done these in the past is that this box here would have allowed me we could have put in a much smaller box at this point. And sometimes in older installations, there was something called a door jamb switch where you open the door and the switch turned on a light in a pantry. That door jamb switch was exceedingly small. It wasn't a light switch you would flick on and off with your finger. Rather, the door itself would turn on and off. And it required an extremely small box, which then allowed us, with only two conductors and one switch in there, to easily accommodate it. If we did it the other way, we would have too many conductors, and we would also have a moret. Let's take a look at three-way wiring. Three-way wiring is the type of circuit where we have continually done incorrectly from level 1 apprentices all the way through to seasoned journeyman electrician. If we follow the schematic, we know that there has to be a hot connection to one of the common conductors on the light switch. And the light switch itself, the common conductor, is typically colored different, or it will actually have the word common written beside it. Between these two conductors, or terminals rather, we have travelers. And then, again, a black conductor connecting our common back to the light itself. A white conductor then travels all the way back. There would be a moret because it is a cable system. We have to cut the cable, obviously. We need a way of reconnecting the neutral conductor. And in this situation, we would then have a 14-2, a 14-3, and again, a 14-2. What's important to realize is that the white conductor is continuous all the way through, and this is the type of installation that we would have to do from 2018 onwards. Again, in the conduit installation, we have a black conductor coming all the way into the common. We would have two separate travelers, and the coloring is really up to the installer. It doesn't matter, it just can't be green or white. And then again, black conductor, and this time the white continues all the way back uninterrupted until it is connected to the neutral bar. Now, the legacy equivalent of this is again a form of a dead end switch. And the problem comes in with the cable installation. So as is usual, we are going to have a black and a white conductor coming from the panel. So that would be a 14-2. Remember, from the schematic, the three-way switch has to connect to the other three-way switch. And so the easiest way to accomplish this is to do a splice in the lighting box. There will be two morets in this lighting box, and the white conductor will have to terminate to the light also. So let's start off with what we know is going to have to take place. Well, we're going to have a moret here. There's my moret. And the white conductor is going to have to connect to the light. So there's my connection all the way back to the light. Now, between my switch and this light, I'm going to have a 14-3. And between the light box and the switch box, I'm going to again have a 14-3 cable. From this one, remember, what is the only thing that these two terminals connect to? They have to connect to these two terminals over here. They are the traveler connections. And so what I'm going to do is take both of them up to the moret. So there's my black and my red. Now from the other side over here, what are we going to do? Well, if we kept the same consistent coloring, as in this one being red connecting here and this one being black, and then we had a white come off of here, well then we would have a problem, wouldn't we? If we connected the white here and connected it back at the light, would we not have two separate white conductors terminating at the light? And that would be a problem. So instead, what the code states in section 4 is that we would have to have taken one of the non-identified or non-white conductors as the return conductor and connect it to the common. At this point, then it's up to you how you choose to do the colors of this connection up here. Commonly, people would have done the white up to the black here, and that way the reds were consistent in their coloring. So again, why are we looking at this? We're looking at this because it's quite probable that throughout your career, you are going to see an installation like this. And perhaps you're going to have to remove the switch and replace it, or remove the light and replace it. And if you have an apprentice with you that undoes all the connections, what the heck are you going to do? Are you going to rewire everything so that it's switch, switch, light? That sounds like a behemoth amount of work. It would probably be substantially easier to remember or understand the other circuit arrangements that are permissible. And as long as they were originally installed pre-2018, it's acceptable to continue using them. Remember, if you're going to use a smart light switch here, you do not have a true neutral available. And because of that, a smart device will not work in this location. It will, however, work over here because we do have a neutral connection. And again, it's easiest to see this distinction by simply showing what conductors would have been required in the conduit system. In this situation, again, because we're using conduit, there's no need for us to do any sort of weirdness with the coloring of the conductors. And in fact, the code won't allow us to. You'll notice in section 4, they are very specific that we're only permitted to use the identified for something other than what it is used or what it's designed for if we are using a cable installation. And that is because you cannot choose the colors in a cable. It is determined by the manufacturer. And so here we have the conduit installation, and you can see very obviously there is no identified or neutral connection back to this switch box. So keep in mind how some of these legacy installations were wired, because at some point it may be quite probable that you will have to troubleshoot something that you may not have had an immense amount of experience with.